artificial intelligence. It's sort of this invisible force now, isn't it? Steering so much of modern life.
It really is everywhere.
Yeah, I mean, it impacts everything from your social media feed to who gets social benefits, even how fast we develop medicines. It's designed for this incredible efficiency.
Unparalleled efficiency and precision. That's the goal.
But here's the really unsettling question, I think. What happens when that powerful automated tech, the stuff built for speed and scale, starts working against people? And specifically, against certain groups who are already facing disadvantages historically.
That's the critical point.
And we saw a massive example of this, didn't we? That Dutch tax authority scandal back in 2020, it made headlines everywhere.
Absolutely, a huge case.
An algorithm supposed to flag suspicious welfare claims just mistakenly labels, what was it, around 26,000 parents as committing fraud, childcare benefits.
26,000, it's staggering.
And the really chilling detail, a huge number of those families, disproportionately so, had an immigration background.
Right, which led to just devastating consequences.
Yeah, derailed lives, severe financial trouble, psychological hardship. It was awful.
Truly.
So today, our mission is kind of to go beyond those headlines. We want to look right under the hood.
Get into the mechanics of it.
Exactly. We're offering you a shortcut, really, to understanding the exact reasons this bias happens. We're diving deep into this 2022 report from the EU Agency for Fundamental Rights, the FRA.
A really thorough piece of work.
They developed and actually tested algorithmic models in two incredibly high-stakes areas: predictive policing and automated offensive speech detection.
Yeah, two areas with massive real-world impact.
And we're here to show you exactly where that bias comes from and how quickly it can escalate into actual discrimination.
And what's really useful about the FRA's approach is how clearly they define bias here.
Right. It's not just about, bad intentions coded in.
Not necessarily. It's defined simply as an output tendency, a pattern that systematically disadvantages certain groups, women, immigrants, specific minorities, you name it.
So the maths can be sound, but the output is still skewed.
Precisely. The systems, well, they inevitably reflect the imperfect, often historically biased data we feed them. The potential of AI is still vast, obviously.
Of course.
But as the report really stresses, we need things like mandatory regulation, robust human oversight. That's essential if we ever want to make this technology genuinely trustworthy.
Okay, let's unpack that, starting with the predictive policing case study.
Yeah.
So you imagine an AI tool, police use it, analyzes historical data to predict where crime might happen next, optimizes patrols.
Standard application concept.
You'd expect it to get smarter over time,
Yeah.
right? More accurate. That's the whole promise.
That is the theory. But the FRA's simulation, well, it revealed this critical, almost self-destructive vulnerability, the feedback loop.
The feedback loop.
This is the core concept, you see. The system's own predictions start influencing the collection of new data. And that new data is then used to update the very same system. So the algorithms are literally influencing the environment they're supposed to be measuring.
So if the initial data has even a tiny, maybe almost invisible bias, say, historically, one area just got reported more often.
Exactly.
That cycle just runs wild.
Precisely. It leads to what the researchers called runaway feedback loops. The bias isn't just maintained. Oh, no. It's actively reinforced. It gets rapidly exacerbated over time.
Wow.
And that results in these extreme, really overestimated results.
So it becomes this kind of toxic, self-fulfilling prophecy. The algorithm points police to neighborhood A. The police go there, they find more recorded crime, maybe simply because they're there more often.
Right. Increased surveillance leads to increased detection of certain crimes.
And that result convinces the algorithm its initial prediction was spot on, creating this closed, damaging loop.
That is exactly the danger they identified. The simulation showed this mechanism directly reinforcing disproportionate over-policing in certain neighborhoods.
And those neighborhoods, and many European cities anyway, often act as pretty clear proxies for ethnic or immigrant origin.
Absolutely. It becomes indirect discrimination baked into the system.
And the researchers, they pinpointed, 3 critical factors driving this. What was the first data issue they found?
Okay, so the first big one is the issue of low or varying crime reporting rates across different communities. The AI relies entirely on official data. right?
The data it's fed.
Exactly. And the FRA noted evidence showing that reporting rates can be quite low among certain ethnic minority and immigrant groups. This challenges the accuracy of those official sources from the get-go.
So if the predictions rely on that kind of spotty reporting.
They inherently fail to reflect the true underlying crime rate across all communities. It's biased from the start.
Which means the AI is basically trained on an incomplete, skewed picture of reality. Day one.
That's right. Then the second factor is differential crime detection. Some crimes are just much easier to detect and record than others.
Okay, like what?
Well, think about car theft, often reported instantly for insurance, right? Very visible.
Makes sense.
Compare that to maybe fraud or certain types of disputes that might not get reported officially. If certain population groups are, maybe historically or even stereotypically, associated with those easier to detect crimes,
I see where this is going.
then the predictions become heavily biased towards those groups over time, even if their overall actual crime rate isn't any higher.
Okay, that's sneaky. And the third factor was more technical, right? About the model itself.
Yes, a technical issue called overfitting. The research showed that even quite simple machine learning models, they use something called naive Bayes in one simulation, can actually accelerate this crisis.
Okay, can you simplify that? Naive Bayes, what does that mean for us?
Well, think of it like a model that trusts its training data too much. It's relatively simple, yeah. And it tends to put overwhelming weight on the initial patterns it sees, even if those patterns are based on skewed data or just random signals, really.
So it stops adapting to reality and just starts seeing ghosts in the data, like echoes of the initial bias.
Precisely. This tendency to overfit to amplify tiny, perhaps random signals is what really accelerates that runaway feedback loop. It leads to these bizarre extremes.
Well, extreme.
Get this. In one simulation, the FRA ran the naive Bayes model randomly assigned 100% of police resources to just one district after only 40 weeks.
100%. To one area.
Despite the fact that the true crime rate was actually set to be uniform across all districts in the simulation, 100% allocation based on this runaway effect.
That is, wow, that's truly alarming. It just proves this isn't some abstract theory, is it?
Yeah.
It's a mechanism that can structurally reinforce discriminatory policing.
Absolutely. Real-world consequences baked into the code and data cycle.
Okay, let's shift gears a bit. While bias in policing deals with physical actions, the online world, well, it presents this linguistic minefield. Just as dangerous, maybe.
Definitely dangerous in different ways, yes.
So let's look at the second big use case the FRA studied, offensive speech detection. This is crucial for content moderation, right?
Yeah.
Every major platform uses it, struggling with the sheer volume of online hate.
Oh, the scale is immense. So platforms are under intense pressure to automate detection. But language is just steeped in context, nuance, history.
Yeah.
Which makes automating it accurately incredibly complex, really, really hard to get right.
And the tests the FRA ran here were quite surprising. They specifically used these invented, obviously non-offensive phrases, things like I am identity term.
Simple declarative statements.
Across algorithms built for English, German, and Italian.
Yeah.
And what did they find?
Well, they immediately highlighted a serious challenge, the false positive problem, or FPR.
False positives. Okay.
That's when a completely non-offensive comment gets flagged as offensive, which can lead to unwarranted censorship, account suspensions.
Silencing people for no reason.
Exactly. Yeah. And the overreaction they documented was swift and it was extreme, particularly for identity terms linked to historically marginalized groups.
Okay, give us the specifics. Which identity terms caused the worst overreaction?
Right. So in the English models they tested, non-offensive text using terms linked to Muslim, gay, and Jew were frequently misclassified as offensive.
Frequently.
On average, text just containing the word Muslim resulted in a 60% misclassification rate. 60%.
Just for using the word.
Yes. And get this, one specific model predicted the simple statement, I am Muslim, as 94% offensive.
94%. If a system is that convinced a simple statement of identity is hate speech, I mean, the training data must be fundamentally flawed, right?
It really points to a massive issue in the data it learned from. And the bias wasn't just in English.
No.
The German model showed high false positive rates for Muslim, foreigner, and Roma, and the Italian models were particularly sensitive.
How so?
Terms like Muslims, Africans, Jews, foreigners, Roma, and Nigerians, they triggered these incredibly strong offensiveness predictions, averaging between 66% and 85% misclassification for simple, non-offensive sentences containing those terms.
Wow. So why? Why is the algorithm reacting like this? Is it just because the training data sets are saturated with actual hate speech, using those specific words?
That's exactly it. These identity terms are so strongly associated with documented online hatred in the massive text data sets used for training
Uh-huh.
that the models basically learn to overreact to the term itself, often completely ignoring the context. They're learning association, not meaning or intent.
So it sees the word Muslim and just flags it, regardless of whether the sentence is, I am Muslim, or something genuinely hateful.
Pretty much. It's a blunt instrument reacting to trigger words it learned were associated with bad stuff.
How did the researchers actually prove the AI was ignoring context and just focusing on single words?
They used a clever tool called LIME, L-I-M-E.
Okay.
So if you think of the AI as a black box, right, it just gives you an answer, offensive or not. LIME is like a tool that shines a flashlight inside. It shows you which specific words the AI actually paid attention to when making its decision.
It highlights the influential words.
Exactly. So they tested the sentence, kill all Europeans, which was, correctly rated as highly offensive, about 73% offensive.
Right.
However, they then simply added the single word love to the end of that sentence. Just tacked it on.
Kill all Europeans, love.
Yep. And that drastically reduced the predicted offensiveness down to 45%.
That's fascinating and kind of disturbing. The model reacted more strongly to one positive word, love, than to the overall violent context.
Precisely. It shows how easily these models can be fooled or misinterpret based on single words rather than understanding the sentence structure or intent. It seems like a huge loophole.
Yes, someone trying to evade moderation could easily exploit that. Just sprinkle in some positive words.
It certainly raises that concern, and the bias went even deeper than just basic identity terms. The research also uncovered intersectional bias and dialect bias.
Intersectional? How?
Well, in the Italian language models, Italian is a gendered language, grammatically. The feminine versions of terms, like musulmana, which means a female Muslim, versus musulmana, the male version, the feminine versions were rated more negatively.
So the models were somehow picking up on this compounded bias. Based on gender and ethnic origin together?
It appears so, reflecting perhaps specific forms of interceptional hatred present in the training data.
And dialect bias, too.
Yes. In the English models, they found a correlation. Text that was likely written using African-American English dialect had a higher probability of being predicted as offensive by the models, even when the text itself was not offensive at all.
Just based on the style of language.
Based on linguistic patterns associated with that dialect, which the model had learned to associate with toxicity, likely from biased training data again, it's truly astounding.
Yeah, that the way someone naturally speaks or writes could be interpreted as inherently toxic by these powerful systems, that's deeply problematic.
It really is.
Okay, so we've established this dilemma. AI has this incredible potential for efficiency, yes, but these biases are structurally embedded. They're in the flawed data that just reflects society, really.
Warts and all.
So the question, as the FRA report puts it, isn't about abolition, is it? It's about establishing systems for genuinely responsible use.
Exactly. How do we make it trustworthy?
So what are the key mitigation strategies they proposed? What needs to happen?
Well, we need to acknowledge this needs action on multiple fronts, legislative, technical. The FRA outlined 4 core actions needed to align with fundamental rights. First, mandatory assessments.
Okay.
Algorithms, especially these high-risk ones like predictive policing, they must be rigorously assessed for bias and discrimination before they're deployed and then regularly afterwards.
Not just a one-off check.
Absolutely not. This can't be an optional step, skipped in the rush to get the tech out there.
That seems like the absolute bare minimum standard, doesn't it? Yet it feels like it's often skipped.
Far too often. Second, we obviously have to address the data quality issues we talked about.
Right.
For policing, things like finding ways to increase crime reporting rates across all communities. That's crucial to mitigate those feedback loops.
Makes sense. Better data in, better results out, hopefully.
And on the technical side, developers need to actively apply techniques like regularization.
Regularization. How does that actually fix a runaway algorithm?
Think of regularization as like a statistical brake pedal you apply during the training process.
Okay. It's
a method to prevent the algorithm from over-relying on those tiny, maybe random signals in the data. It helps stop the model, like that naive Bayes example, from overfitting and generating those extreme runaway predictions, like sending 100% of resources to one area based on noise. It encourages more balanced, less extreme models.
Got it. So it dampens the extremes.
Essentially, yes.
Yeah.
Third, language diversity is vital. The big biases and just poorer performance they found in the German and Italian speech models compared to English.
Yeah, that was stark.
It really highlights a serious lag in natural language processing research in the tools for many non-English languages. We need proper funding and promotion of research for those other languages.
To ensure the tech works fairly for everyone, not just English speakers.
Exactly. Equitable performance. And finally, transparency and external oversight are just paramount. We have to overcome this black box problem.
Where nobody knows how the AI actually works.
Right, often shielded by, proprietary commercial limitations. Companies, public bodies using this stuff, they need to be required to provide access. Access to the necessary data, the resources for independent researchers and oversight bodies to actually test for bias.
So people can actually check under the hood.
Without that access, bias just stays hidden. Accountability is impossible.
This has been a really eye-opening deep dive, seriously. We've seen how systems designed for pure efficiency, whether they're doing welfare checks, optimizing policing, moderating online chat.
All seemingly neutral tasks.
Yeah, but they can so easily embed and then amplify societal prejudices, disproportionately targeting groups who are already disadvantaged through things like runaway feedback loops and these weird linguistic biases.
It's baked into the process if we're not careful.
So we'll leave you, our listener, with this final, maybe provocative thought to carry forward. The simulation on feedback loops clearly showed that bad predictions influence people's behavior, right? Resource allocation shifts over time. Harm happens.
The predictions shape reality.
So if poorly developed algorithms can recreate existing forms of discrimination that we already know about, what new, maybe unseen forms of profiling and disadvantage might these really complex, widely scaled AI systems create next? Forms that fall entirely outside our current understanding of protected characteristics like race or gender.
That's a crucial question. We're really only scratching the surface of how AI might create new ways of grouping people, maybe based on complex behavioral patterns or combined demographic data.
Things we don't even have names for yet.
Exactly. Profiling identities that might bear no obvious link to existing protected grounds. The risk of creating entirely new categories of disadvantaged individuals based purely on how algorithms characterize them from data, it's very real.
Something really crucial to consider maybe the next time an algorithm serves you an ad or a news feed or makes a decision about you.
Definitely food for thought.
Thank you for diving deep with us today.
My pleasure.
We'll catch you next time.